channel. Today's topic is triangle congruency by side, 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 and side, angle, side. If you haven't already, down in the description there are some links to some guided notes that you can follow along with if you'd like. Feel free to click on those, print them out, and write some things down. So in the previous lesson, we've explored what it takes for any two polygons to be considered congruent to one another, which included all their corresponding parts, meaning their congruent sides and angles all have to match up. In the next few lessons, we're going to zero in specifically on about what it takes for triangles and proving triangles congruent to one another. Now, although triangles have 3 sides and 3 angles, for a total of 6 parts, we're going to find out that based on the properties of triangles, we don't truly have to investigate all 6 parts to be able to come to an accurate conclusion about congruency. We're going to learn a few shortcuts today. So the first shortcut we've got is the shortcut of the side, side, side congruency postulate. So to investigate this, I'm going to use some pieces of paper here. So these pieces of paper are of a certain length, and I've got 2 sets that are identical. So this length is the same as this length here matches here, and these 2 lengths are the same as well. So the trick here is I'm going to try to take these 2 sets of pieces of paper and make 2 triangles that are different. So if I took this set and matched up the sides, kind of have to flip it around a little bit to make sure I do have an actual triangle. Okay, so there's a triangle with these 3 sides. Now the question is there any way that I could take these 3 pieces of paper and make a different triangle than this one? Well, you could kind of move the pieces of paper around a little bit, and I put them together, and you think, well, they look different, but are they different? Even though this triangle is rotated, when you look at them, these triangles really are the same. Right, is there any way I could put these together and make a different triangle? Say maybe I wanted to make this top angle a little larger. So I open those up a little bit. Well, I can't make a triangle any longer with the lengths of sides that I have. So the deal is, if I have 3 sides in one triangle, congruent to 3 sides of another triangle, there's no way I could make a different triangle with that setup. Okay, the angles kind of fall into place based on the rigidity of the sides of a triangle. Okay, I can't make them larger or smaller. The angles are going to have to fall into place. So this is what the side, side, side postulate says. So the side, side, side postulate, or how we abbreviate it, SSS. The side, side, side postulate says that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So in this picture right here, I've got all 3 sides marked congruent to all 3 sides in this triangle. This is enough based on this postulate to say that these 2 triangles are in fact congruent. Now, why is that a shortcut? That's a shortcut because we didn't have to investigate anything about the angles in these 2 triangles to make that decision. Okay, so 3 pieces is all that's needed to say that those 2 triangles are congruent, just the 3 sides. Okay, similarly, we've got this same situation, a little bit different. Oops. Okay, we've got the side angle side postulate. Side angle side postulate. It is what it sounds like. If you have 2 sides and the angle in between those 2 sides mark this information, 2 sides, and then the angle in between those 2 sides, like this. Okay, this postulate says that this information would be enough to say that these 2 triangles are congruent. Okay, so to define it, the postulate says if two sides in the included angle, included meaning in between the two sides, if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then that's enough information to say those triangles are congruent. Okay, and you can kind of look at it the same way as pieces of paper. Let's say I didn't have that third side. Maybe that third side was missing. So I have a situation like this. So I've got two sets of two sides, and then those two sides being put together at this vertex at an angle that is the same as the angle over here. Now obviously those aren't triangles, but if I said, hey, let's make a triangle out of this setup, what's the only way to make that triangle? Well, you gotta connect the third side. Okay, you gotta connect these 2 points right here. But is there any way I could do that differently in this situation here? Well, no. If I put a line between those two, obviously these two sides are going to have to be the same as well, which would then give you all 3 sides. So if I have a side, an angle, and a side in that order, side, angle, side, where the angle is in between those 2 sides, this is enough to prove that those 2 triangles are going to be congruent to one another. Okay, so a quick example here, and then we'll get into some proofs. Okay, so let's take a look at something like this. So again, the triangles don't have to be orientated the same way, they can be flip turned. But if you see something like this, this is where you got to be a little bit careful. And you look at that and you see, yep, you got 2 sides and an angle, 2 sides and an angle in both sets of triangles, yep, they're congruent. Well, here's where you got to be a little careful. Here, the order is a side, then an angle, and then a side. Okay, so the angle is in between the 2 sides. Is that set up the same over here? You can see that angle is not in the right spot. You've got the side, then a side, and then the angle down here at the bottom. Okay, so these angles are not in the same spot. Okay, they don't match up. This angle should match up to this angle. If I have side, angle, side, right now I have side, side, angle, that's not the same thing. So if I said, are these 2 triangles congruent based on the information? You'd have to say no. This is not side, angle, side, not side, angle, side, because the information is not marked in the correct spot. Okay, so let's look at a couple of proofs. Okay, so let's set up this one. So we've got a situation of 2 triangles kind of back to back on one another. Let's wait on a proof. Let's do a quick one real fast. So let's say that this is the information that you have. Okay, so marked in this picture, that's the information. The question is going to be, is there enough information to prove that these triangles are congruent? And if not, what other information would be needed? Okay, so if we look at this picture, we have to decide, is that information enough? So based on our 2 postulates, we've got side, 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 and side, angle, side. That's 3 parts, and you can see we only have 2 parts that are marked. So we've got DA congruent to DC, those 2 segments. We've got this angle ABD, this angle CBD, those 2 angles are marked. That's only 2 things. So this is where we have to investigate based on the picture. Is there anything else that we know from the setup? And you can see, if you've done a couple of lessons on congruency, then you know that this middle side here, DB, that middle side, you can mark that side congruent to itself. Both triangles share that side due to the reflexive property. So now we've got 2 pairs of sides in an angle. And again, you might think, well, it's side, angle, side. Careful. Where's the angle in this case? It's over here. The 2 sides that I have are over here. So if it's side, angle, side, the angle that I would need would have to be in this corner over here. Okay, so right now, currently, we do not have enough to say that these 2 triangles are congruent. So then the second question was, what else do we need? Well, if we're trying to get side, 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 that just means all 3 sides have to be congruent. So what's the third side in each triangle that would need to be congruent to one another? That would be AB, necessary to be congruent to CB. Okay, so if I wanted these two triangles congruent, what else would I need? I would need AB congruent to CB. Okay, let's say I didn't have that. But I wanted to say these two triangles were congruent by not side, 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 but side, angle, side. Well, that would work as well, side, angle, side. What other angle would have to be congruent to get side, angle, side? We said that this one wasn't enough. We needed the angles to be in between or included between the two sides. So which angles would those be? Those would be over here. Would be those two angles. So these two angles are A, D, B. So this would make side, side, side. If I wanted it side, angle, side, I would need angle ADB congruent to this angle down here, which would be CDB. So either of those pieces of information would give me enough to say those two triangles were congruent. Okay, now let's get into the proof problems. Everyone's favorite. These won't be too bad. Okay, so let's go this route. So again, two triangles. Switch up the letters here. Okay, so in this picture, two triangles make this kind of bow tie shape. I'm going to give you a few pieces of information. So let's say given segment NK is congruent to segment LK. And let's also say that K is the midpoint of JM. We're going to try to prove that triangle JKN is congruent to triangle MKL. So that's our goal. Prove that these two triangles are congruent. Okay, so our proof setup, once again, we got two columns, we've got statements on one side, reasons on the other. Okay, so statements, the reasons why they're true. Now, how many steps does it take? Just depends. Just depends on what we've got. Okay, so the first step on your two-column proof problems is to look at what's given, and I always recommend marking that in the picture. So you have the picture here. If you mark the information that you have, visually you'll be able to see things, you'll be able to kind of map things out a little bit better. So I always recommend, if you're given something or if you know something is true, just mark it in the picture. It'll make things easier. So the first thing you see, NK is congruent to LK. So NK, this segment here, congruent to LK, that segment there. Okay, so we know that that's true. We're going to make that statement. So we know that segment NK is congruent to segment LK. How did we know? It was given. We've got something else that's given. It says K is the midpoint. K is the midpoint of JM. So right there is halfway between J and M. So we're going to go ahead and make that statement. We know that's true because it is given as well. So K, I'm going to abbreviate a little bit here, is the midpoint, MP, of JM, which is also given. K is the midpoint of JM, that is given. Okay, so we've got one pair of sides that are congruent. In order to prove the triangles are congruent, we either need all three sides or two sides and an angle that's in between. So based on this setup, what else do we know? Here, K is the midpoint of JM. If K is the midpoint of JM, which two segments would have to be the same? Well, this segment JM gets cut in half, so the two halves would be these two pieces here. So we know that JK is congruent to MK. Those two segments are the same. So number 3, we're going to say JK is congruent to segment MK. And the reason behind that, how did we know that those two segments were the same? It was this piece of information here. The definition of a midpoint is a point that divides a segment into two congruent segments. So we're going to say that's the definition of midpoint. Definition of midpoint. Okay, so now we have two pairs of congruent sides, which is a good start. We either need one more side or we need the angle that is in between those two sides. And if you look at the picture, I think you can tell pretty quickly whenever you have this bow tie shape, don't forget vertical angles right here. vertical angles are always the same. And that's our third piece. That's the part that we needed. So we marked it in the picture. We know it's true. Let's go ahead and state it. Kind of write that in space here. So number 4, I'm going to move down here. So number 4, I've got angle JKN and angle MKL, which are congruent because they are vertical angles. So angle JKN is congruent to angle MKL, and that is because they are vertical angles. Vertical angles. All right. So based on our postulate, side angle side, you can see the angle is included in between the two sides. So here is a side, there is the angle, there is the side. So side angle side, we've got enough information stated. Last step on a proof, what are we trying to prove? Have we done enough? Sure have. So step 5, last step, we now know that triangle JKN is congruent to triangle MKL. And that is because of the side angle side postulate. Two sides in the angle included in between the two sides are congruent to the same on the second triangle. There it is. Okay, let's do one more. Okay, try to make this one a little bit trickier. Okay, I see this situation happen a lot. Okay, what the heck do we have here? So we've got V, Y, Z, W, X. Okay, so here we have a situation where we've really got a couple different triangles here. I can think of a lot. You got triangles here, you got one here, you got this whole thing's a triangle, this whole thing's a triangle. Let's get you some given information. Let's say that Vx is congruent to Wy, and let's say angle Vxy is congruent to angle Wyx. And what we're trying to prove in this case is that triangles Vyx and Wxy are congruent. Okay, so Vyx and Wxy. So let's look and see what two triangles we're talking about. Vyx, so we're talking about this triangle right here, and then Wxy, this triangle right here, and they kind of overlap and meet up in the middle on top of one another. Okay, so that's what we got. Statements, reasons. Okay, once again, start with what you know. We are given one pair of sides, Vx, congruent to Wy. Let's mark those. Vx, so that's this whole side right here. So that's these two segments kind of combine. I know they kind of cross in the middle, but we got this whole segment, Vx, and this whole segment, Wy. We know those are the same. So let's state that. Vx congruent to Wy, which is given. Okay, one more piece of given information that we've got. Angle Vxy, so follow the path, Vxy, that's this corner right there, is congruent to Wyx, that's this corner down here. So those two angles we've got congruent as well. So angle Vxy congruent to angle Wyx. Also given. Okay, so from the given information, we've got one pair of sides, we've got one pair of angles. And it gets kind of confusing because they're kind of laid over on top of each other. Now what I want to do real quick, I'm just going to kind of go down here and show you. What would happen if I took those two triangles and kind of slid them apart so where you can see each triangle individually. So Vyx, you've got this triangle that kind of looks like this. And then the other side, you've got WYX, which is really the same looking triangle, it's just kind of flipped over. So it looks kind of like this. Okay, so I've got the two triangles split apart. If I put those points, okay, I really have this situation. Now I'm going to go ahead and mark VX here, WY, or WX here, and then the two angles, which would be these two angles right there. So this is really what I have if I take those two triangles and separate them. Now what do you notice? They're overlapped over here. They're overlapped on top of one another. And you can see that the two triangles share, this is a Y, the two triangles share that bottom side. So if you look at the bottom side, you've got YX for the base of this triangle, you've got YX for the base of this triangle. It's the same length, right? They share that side at the bottom. So I really know that these two segments are the same because it's one segment, it's the same. Which is really the third side that I need to get side angle side. You can see the order here, side angle side in this picture. So I can mark this third side that they share, that they overlap down there at the bottom, and now you can tell that we've got enough information, we've got side angle side. Okay, so let's go ahead and get that into our T-chart. So that third side down here, I guess the second side, down at the bottom I've got YX. So 3, I've got YX is congruent to itself, YX. Once again, when they share a side, it's the same length. We're going to call that the reflexive property. Reflexive property, and that's 3 parts. We've got 2 sides. There's the side, the angle in between them, and the other side, side angle side. That's enough. So 4 steps on this one. We have enough information. What are we trying to prove? We now know that triangle BYX is congruent to triangle WXY. And once again, we've got side angle side. All right, there it is. All right, thanks for watching. If this was helpful, give it a like, thumbs up. If you know somebody that this could also benefit, share it with somebody. And if you want to see more videos, feel free to subscribe. Thanks a lot for watching.